For number 1, we have the following data. I kind of switched these two to make sense more in my head. Graduated cylinder has 43.15, graduated cylinder plus ethanol 109, initial mass of candles 24, initial temp was 4, final temp was 33, and final candle was 24 something. So we have two questions. We want to know what's the delta H and then what's the percent yield. So let's do this one first. Remember, delta H is equal to MC delta T, and this is of the thing that it is warming up. So I believe it is ethanol. That is the specific heat of ethanol, I forgot to write it down, is 0.588 calories per gram degree Celsius. And it was also given the density is 0.789 grams per mole. So these are two properties of ethanol. Let's see what we need. So we do need to know the mass. So we could get it from here. So if we subtract these two, we'll get the mass. So 109.42 subtracted by 43.15, and I get 66.27 grams of ethanol. The specific heat ethanol is 0.588 calories per gram degree Celsius, and ethanol went from 4 to 33. 4 to 33, so final minus initial, which was 4. And this is how much heat was absorbed. So I just plug that into your calculator. So 33.4 subtracted by 4, and I get 1145.6. And I started off with, let's see, 3 sig figs. So let's just change it to 3 sig figs. So this should be about 1150 calories. So if we're using sig figs, it's 1150. If not, we have that kind of answer. All right. So for B, we want to know how much the percent yield is. So let's say I use this one, but in my calculator, I'm going to keep it this one. This is how much we got. This is how much it should have gotten. But remember, this is per gram. Now, this is not per gram. This is whatever we did. This was out of, let's see, no. Let's see how much was burned. We need to figure out. So we need to find out how much is burned by this and this. So let's see if I could do this. 24 minus, 24.23 minus 24.42. So my mass that I burned was 0.19 grams. So I'm going to divide this by 0.19 grams. So 1145.6 divided by 0.19. And I get about 30 calories per gram. So, and we're going to see how does it do with given. So 6,030 divided by 10,000, which will give us 0.6030, so about 60% yield. Okay, so we started off with, let me see, sig figs, 3 sig figs, so technically 60.3. So let me do that more correctly. 60.3%. So that's the percent yield that we have. And I believe that finishes number 1. All right, for number 2, we have tridecane. And we know the following. We know it's C something H28. Remember, all hydrocarbons has a mass of, or has an empirical formula of CnH2n plus 2. So I'm going to subtract 2 from 28. So that's going to give me 26. Divide that by 2, which will give me 13. So tridecane is C13H28. I want to find the molar mass or the hydrogen mass composition. So 13 times 12.1 0.01 plus 28.28 will give me 184 But I just want to know hydrogen, so that will be 28.28 divided by the molar mass. Oops, shoot. 28.28 divided by the molar mass will give me 15%. Let me check my answers and make sure I'm right. 15%. So this will give me about 15.3. The boiling point of pentadicane, so this one's C something 32. So remember, minus 2 divided by 2 will give me 15. So this one has a higher amount of carbons. The more it is, the higher the boiling point is. So, let me make sure. So this will have a higher boiling point. So I'm going to undo that. So this will have a lower. So tridecanoate, since it has less carbons, it's going to have a lower boiling point than C15. Now it's the opposite. This actually has the higher boiling point. This has the lower one. So that will be 2. We're going to combust it. So we have C13H28 plus some O2, which will give us some carbon dioxide and some water. Balance equation. We have 13 here, so 13 here. 28 here divided by 2 is 14. 14? 14. That means I have 26 oxygens here plus 14 oxygens, which will give us a total of 40 divided by 2, which will give us 20. For letter C, if we have 2.12 of tridecanoate, we want to know how many moles of that. So I'm going to just convert this into moles. So 2.12 grams. I'm going to use the molar mass. So 184.41 grams per mole. And that's going to give me 2.12 divided by 184.41. Should give me 0.0115. All right. Now we're going to look at the ratio. So oxygen is 20. So I multiply that by 20. I get 0.229. So let's see, 23. This is number 2. Let's see how many sig figs we have. Huh. 3. So I'm going to keep it with 3. So 2.30. And then we're going to do the same thing with, why did I write O2 twice? Let's see, what's the other one? C. Oh, this is grams. Okay, so now we have moles of oxygen. We need to do the same thing with grams. So we have 0.230 moles of O2. So we want to get rid of it. So we want grams. So grams on top. So we want to find so that's 16 times 2, which will give me 32. So 0.230 times 32 will give me 7.36 grams. Let me make sure I did that right. Let me check my answers. Yep, 36. All right, last one, letter D. A giant cookie contains blank grams of blank, but we know it's 4 calories, so that has to be sugar. Remember, SF 49ers, so San Francisco 49ers, sugar, fats, 4 calories, 9 calories. So 4 goes with the sugar, 9 goes with the fats. So here is that. Here's 9, so that means this is fat. So I have the following. I have a total of 230. So I don't know this one, but something times 4 will equal 10 times 9 will equal 230, since all the calories are either from fats or sugars. So then we have 4x equal or plus 90 equals 230. Move the 90 over, so 4x is equal to 140 divided by 4 will give me 35. So x equals 35. So that means we have 35 grams of sugar, 10 grams of fat, and that's going to make our cookie. For number 3, we have 4 grams of heptane, which is 102 grams per mole. And we want to figure out the rest, and this is a combustion. So we have C, hep is 7, H, 2 times 7 is 14, plus 2 is 16, plus O2 would then give us carbon dioxide and H2O. Balanced equations. So we have 7 times 16 divided by 2 is 8. And then 7 times that's 14 plus 8, 22, 11. So here's my balanced equation. And we want to figure out these. We have 4 grams. So 4 grams. We want to get rid of that. So mole per gram. And that will give us the moles of that, which then we're going to multiply by the ratio 7 and 8. 11, 7, 8. So 4 divided by 100.2, so 0.033, and then multiply by each one. So 439, we start off with 2, so 0.44 moles of that. Zero 0.28 32. Okay, number 5, we have propane, which has a molar mass of that and that. And for A, it says how many C's. So if it was propane, so remember prop is 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8 H's. So that's C3H. 2 times 3 is 6 plus 2, 8. Propine, this has a triple bond, so C, 1, 2, 3, C, C. So 1, 2, 3 H's, 1, 2, 3. This has C3H4. So it has 4 fewer H's, and we want to know how much moles of CO2 is going to make. So let's have the equation. So that's C3H4 plus O2 will yield carbon dioxide and water. Balance the equation. So 3 here, 2 here. So 3 times 2 is 6 plus 8, 4. So that is my balance equation. So we have 0.21 moles of propane. Then how many CO2? So 3 times that, so 0.63. If we have 2.1 grams of combust, let's see how much energy is produced. So for number 5, we know that this makes 463. So we have 2.1. So 2.1 grams. We want to have the molar mass. Did we do it? Let's see, I believe so. Yep. By 40.065 moles per gram. And let's do that. So that will be 2.1 times, or sorry, divided by 40.065, so I get 0.052 moles. So we have this per mole, so we're going to multiply this by 463 per mole, and I believe the units for this one is kilojoules. Nope, it's calories. And what I want here is that. So then we're going to multiply that by its molar mass, or its calories. So let's just do this first. Times 463. Oh, shoot. Okay, so I get 2426. And this is in big cal, and I want it in, let's see, kilojoules. I don't know what per something is. This is kilojoules. So we want to change this. We have, let's see, 4,000. Actually, I think I only have to do it once. It's 4.184 calories per, or joules per calorie, but now we're going to do kilojoules per 1 calorie, or joules. Joules. So 21 times 4, 184. I get 10. Oops, 101. 537. So 102 kilojoules. And let's see, 5, I think that's it. Oh, 60. So if we have the following, make sure I'm doing it right. So we're going to burn some paraffin, which is C25H52. And 73 milliliters of water is going to go from here to here. So delta H is equal to 73 grams times 1 times 42 subtracted by 4.5, 37.5 times 73. So 37.5 calories is going to be equal to delta H, and 60 is asking for what's the percent efficiency. So this, let's see, divided by 0.57 will give me calories per gram, and I get 4,800. Let me make sure this is right, because I got 52. I wonder why. What did I do differently? 75? Did I do it wrong? I did my answer wrong over here. So let's see. Oh no! I put 42. This is 45. So there's my mistake. Okay, so it's not that. So let me redo it again. So 45 minus 4.5. So instead of 37, it's 40.5. So that's where I differ from my answer. Times 73. So I apologize for my mistake. This is not 27. It is 2356. Or sorry, 2956.5 divided by 0.57. So sorry, I made a mistake. I made a mistake right there. So the answer is 5186. And then if you divide it by 10,000, so about 52%. So sorry for the mistake, but that would be 60.